Okay, so probability using a counting technique, and this is very much a counting technique because it's a bit unorthodox how to solve this question. There isn't quite a set formula for it. But here's the gist of the question they've given us. There's 8 total friends. Sorry. What is the probability that 2 out of the 8 have the same birthday? Okay. So this question can be hard to set up in the way that they've worded it. They've worded it so that you find out what's the probability that it does happen. I'm going to tell you that it's actually going to be much easier and a lot less calculating to figure out what the probability is that none of them have the same birthday. Okay, so that would essentially be the opposite of this, right? If 2 of them have it, then if none of them have it, then that's essentially the opposite of this idea. So let's set it up like this. We'll talk about our 8 friends. So we have friend 1, and then we'll call him number 1, number 2, 3, 4, 5, 6, 7, 8. So we're going to have 8 placeholders for all of these people. I'm going to make him special so that we can make 8 lovely friends. Okay, and what we need to do is figure out the probability, like we said, that they none of them have the same birthday. So the very first person here, who I'm drawing everything away from, this guy here, the probability of him having a birthday. It can be common to think, okay, what's the probability of his birthday? Well, it's 1 day out of 365. But actually, his birthday is the one that's not really that important. It's independent. It doesn't matter what his birthday is. Let's say his birthday is January 1st. Okay, so he happens to be the first baby of the new year. Once we have an original birthday, it's all of the birthdays following that become important. And essentially, we want to make sure that none of them are the same as this January 1st birthday. So what that means is person number 2, he can have any birthday all year long as it's not January 1st, which means there's 365 days. Yeah. So he can have 364 of them. So this is where the equation starts. You could say 1 if you want it times that because it won't change anything.
Yeah.
But his birthday is unimportant essentially for this setup. So the actual calculations, there's only going to be, even though there's 8 friends, there's only going to be 7 real fractions that we deal with in this counting. So the next person following has, it can't be January 1st.
363.
Yes, and it can't be whatever person 2's is. So that's 2 options out of the year taken away. So that's 363 options over 365. Okay, and then that pattern continues. 362. I'm not going to keep writing the denominator. We're just going to assume it's the same all the way through. So that's 1, 2, 3 times 361 times 360 times 359 times 358. Okay, and I'll just draw little arrows so that we see where they're all connected. The denominator is the exact same every single time. So I just kind of kept it going there. So your equation essentially is all of these values on top divided by, and because there's 7 countings, you can kind of just say it's 365 to the power of 7, whatever that is, and we can take all of our values on top. So I'll just highlight it here. So your equation is essentially what I highlighted on top divided by 365 to the power of 7. So I'm going to see if I can bring up a nice calculator here. I think I have one. Numerics. Let me see. It's a decent one. Oh, I know I don't. Let's type it in. I think that's what it's called. Yeah, okay. So we have our numeric calculator. So let's kind of type these all in. I'll move this over on this side. We want 300 and... Yeah, so let's put this in brackets, right? Because there's going to be a lot to it. 364 times... So we're going to do all of the numerator first. 364 times 363 times 362 times 361. Let me know if I type it in wrong.
Okay.
Times 360 times 359 times 358, I think was the last value. I'm going to go over and check. Yeah. And then all of that needs to be divided by, in brackets, 365 to the power of 7. Okay. So these are actually massive, massive numbers.
Yeah.
Let's see how it calculates. There it is. Tells us that it's 0.92568. So I'm going to kind of round, or actually, no, we'll keep it. Can I copy this value? I think I can.
Yeah, I think last time you were able
Yeah,
to.
I think I was able to. So let's see if we can just kind of paste it in here. Paste. Yay.
Yeah.
Okay, so we have this ridiculous number, and this is the probability. Remember, we stated at the beginning, this is the probability that none have the same birthday, but that's not quite what this question was asking. Okay, so we calculated the probability of not having the same birthday. So what we need to do is we need to take the number 1 and subtract it by what this finding is, what this value is here. And the reason being is because 1 represents 100%. It's all possibilities, okay? So in other words, what we're saying is these are the possibilities where our answer doesn't work, so our answer has to be in the rest of the other possibilities. So when we take 1, I think I can do it over here. Can I save my old answer? I can. So 1 subtract my old answer should give me, here it is again. Oh, I like that I can copy and paste now.
Yeah.
Boom. Here it is. So again, we obviously don't write the number to that decimal place, but let's say, again, because it's probability, we're talking about percentage. So when we talk about percentage, you would multiply this by 100 to get your percent, so our decimal place moves over 2 units. So we're talking... Oh, no, sorry. I said that wrong. That's not correct. Did I say that? Oh, now I need to think about what I'm doing. Hold on. I second-guessed myself there, but
Not bad.
previous me is smarter than the thinking me there, apparently. And it was right. So you move it over, and the idea is that it's 1, 2, sorry. It is about 7.43% chance that 2 out of 8 friends... we'll draw the guy as a friend instead of writing the word, have the same... We'll draw a wonderful cake for birthday. Birthday, yay!
My friend and her sister. My sister and her friend had the same birthday.